So without wasting any more time, the question I think that we're gonna do, the last question for today, we're gonna do Cat Lemonade's question. So I'm not gonna write everything so that I can actually go through everything with you guys. But Cat's question has an equation which is Ti, which is an S, which is already a solid. You should already have your eyebrows going up because we know when we're talking about Kc, equilibrium constant, we do not include solids. So it is in equilibrium and it's got TiCl4. So I'm just going to read, and it's also solid, Cat Lemonade's question. Initially, 336 grams of titanium and 426 grams of chlorine gas are mixed in a sealed container of 2 cubic decimeter at a certain temperature. At equilibrium, is found that 288 grams of titanium is left in the container. Step number 1, they've given us the information in grams, which we must convert into moles. So initially we have 336 grams of titanium. Now remember, 1 mole of titanium is equivalent, if you look on your periodic table, 48 grams of titanium. I'm going to work that out just now. And then we are told we have 426 grams of chlorine gas. Remember, it's diatomic. 1 mole of chlorine gas. I forgot my 2 there. Remember, 1 chlorine is 35.5 grams. Times that by 2 because it's diatomic. Okay, that should be fairly easy. I think I get 71 grams of chlorine gas. And then the last one, we are told that equilibrium, we have 288 grams of titanium. 1 mole of titanium is equivalent to 48 grams of titanium. Let me just close all of that. Let's just calculate that so that we see what we get. Let's do the first one. So if I have 336, remember this is over an invisible one, all over 48 gives me 7. Let me do the next one. I think I'll be able to remember. If we've got 426 divided by 71 gives me 6. Okay, let me write that. So for the first one, I get 7 moles. So initially 7 moles of titanium were included and 6 moles of chlorine gas were included. Let's do the last one. So let's see, Kat, I can see where you might have struggled because having to convert all of this is quite tricky. But remember what I said before, it is part of stoichiometry. And then we get 6 moles of tin. Now guys, I'm not going to do all of this because we are running out of time, but another way to do this, you could have used N is equal to small m over big M, molar mass over molality, where you get 336 over, I'm doing the first one, I'm doing this one, over 48, should then give you exactly the same thing, which is 7 moles of tin. So you can either use this one, or you can use my one, which I call conversion factors. So without wasting time, let's continue. I'm going to rewrite the equation again, and then I'm going to plug in. I've got some tin, which is a solid, plus 2Cl2, which is a gas, at equilibrium. It is TiCl4, which is also a solid. Using my method, what we start with, what you've used, and what do we have at equilibrium. Initially, we've just calculated it, 7 moles. They gave us the grams. We had 6 moles. Remember, if this is what we put in, we do not have any products as yet. Then we're told at equilibrium, we had the 288 grams of tin, but we have converted that, and we found out that it's actually 6 moles of tin. Now remember, it's a ratio of 1 is to 2 is to 1. I've got 1x, I've got 2 x's, and I've got 1x. So 7 minus something must have given me 6. So if I say 7 minus what will give me 6? 7 minus what will give me 6? 7 minus 1. So my value for 1x is 1 mole. I can then take away this, and I can put 1 mole. Here I've got 2 x's. If I've got 2 x's, wherever I see an x, I put a 1. So 2 times 1 will give me 2 moles. Will give me 2 moles for this question. And for here, a value of 1x is also 1 mole. So let me just take this off, And this is then what you'll have at equilibrium and what you're going to subtract. 6, remember this is being used up. 6 minus 2 will give you 4 moles at equilibrium. And this is being added, so 0 plus 1 will give you 1 mole at equilibrium. So guys, you can then take this question and continue it as how I've showed you. After this, you're going to use C is equal to N over V to find your chemical concentration at equilibrium. And then from there, you are able to calculate your Kc. Otherwise, these questions are all repetitive. All you need to do is just practice, practice, practice.